So here I've got some code that isn't quite working right. And it's not a lot of code, but the trick is I need to really wrap my head around how it works and how the different parts of it are fitting together. This is that same code in CodeWalker. And as you can see, I can already very easily start understanding this code better. I can understand how it fits together, how the functions map together, and what variables are used in what order, things like that. But I would like to look at this in VR. So we have a new tool called the Device Gateway. And when the Device Gateway is active, you'll see a little icon for each of the devices that you have registered with this copy of CodeWalker. In this case, we only have one. It's the VR headset. So for the rest of this, we're going to do this in VR. Okay, so if you look right here, you'll see that this is actually almost identical. The only difference is the color. So we're going to take this. I'm just going to walk over here to this board here and just expand it a little bit. Now, I thought this would be a good idea. I thought this would help me basically see the code a little better. But it turns out it isn't great for tracking. So we're going to see how we can do here. All right. You can manipulate the horizontal and vertical offsets, and you can also scale things just by clicking and dragging with both hands. But so let's talk about this code for a second. So one of the things that stands out immediately is this is trimmed code, as you saw earlier. And that shows me something interesting, and that is that here at the start, if we were to just go in here to the start and say collapse and then expand one level, you would see all of this stuff here. But when we expand all levels, and then if we do the trim, you'll notice that it is substantially fewer calls. There are actually only 4. And the reason is because it has collapsed all of that other information into this here. So if a function is being used somewhere, it doesn't show its declaration or its definition. It shows it in the code, in the context where it's actually used. Okay, so one of the things that stands out immediately is we've got 2 things right here at the bottom that are not in the rest of the code. That means they are unused code. And if we zoom in, if we were to go look in the code itself, we would find that calculate footstep position and show me where are both unused code. So we don't need to look at those right now. And start is the first thing that happens. And all I'm doing is I'm setting this previous position right here. So really what I'm interested in is this check for step right here. This seems to be where everything interesting starts. So what I want to do is I'm going to zoom in a little bit and then go here, and I'm going to go to show only me, and that is going to give me just that part of the code. See, it trimmed everything else off, and it's just showing me that part that's actually active. So we're going to take a look at that, and then furthermore, let's see what else we want to do here. We're going to go to settings again. We're going to pull this out just a little bit more and move it over a little bit there. This is a lot. If I wanted to just walk back and forth on this, I could. But you know what I could do is I could also grab this part right here and just move it to a different part in the room. So I'm going to take my sleeping dog over here. I'm going to put it right over the sleeping dog. So this is the move foot section of the code. And from here, I can see that it's going to do some things. It's going to get a localized direction, calculating the pelvis position on the ground, which is basically directly under the head of the person when they're standing, if they don't have a pelvis tracker or a chest tracker. And so that's going to get me my localized direction. The localized direction I can tell is being used here also. It's basically being used to calculate the first foot and the next foot. So I've got that. So in other words, if the localized direction X, you've got your foot and your other foot, and maybe this is your axis, but you're actually facing this direction, the localized direction will go across here. And so that'll allow me to basically say, okay, well, if X is on this side, it's going to be right. If it's on this side, it's going to be left. So that's what's going on here. I'm using that to determine which foot is the first foot. So if it's less than 0, the first foot's going to be left. If it is greater than 0, the first foot's going to be right. And so that's what that is. And then we're saying so the first time through this, if it's a follow-up step, and then we do this stuff. So it's not, like if it's your first step, then that's going to be the case. If it is a follow-up step, we want to also say follow-up step is false. So we don't care about changing which foot is in use if the follow-up step is true, which makes sense. Okay, so now we're down here in move foot, and move foot, we want to, this is the important part here. And in fact, what I could do is I'm just going to take this part here and move whoa, there's a pipe in front of me. Move that right there. And we'll pull move foot over here and look at this. Okay, so here we're doing calculate footsteps. We've got our target position. Calculate footsteps. I'm curious how often we're using calculate footstep position. So we're going to go here to search, and we're going to type in calculate. Calculate. There we go. So we're using it in these positions here, and I don't think we're using it anywhere else in the code. No, we're not. Okay. So this tells me that this particular function, I could actually probably cache the results of this, possibly, maybe. Let's see. If I do a heat map, it's going to show me all the nested loops, and immediately it tells me there's a while loop right here, and I am calculating the footstep position in that. That's interesting. That's interesting because that's going to change. This pelvis position on ground will change every time the person moves, and we are inside a what do you call it, coroutine. So that's yield return null is what's happening there. So this is basically what my point is this is fine, and I probably should not cache the results. For example, if I were to cache the results here at the top on this one, then during this loop, if the person moved their head around, my cached result for the target position would be invalid, or would be at least not right, right? Okay, so I'm going to clear out those search results. And that's the kind of thing that you can immediately get from this. And using the search feature, if I wanted to, I could say, I could find all the search results there for that, and I could also search for let's say next NEXT, and we'll see what that pulls up. Okay, so we can tell that we've got move the last foot is here, and it calls into this. The reason it's coming up on this one is if you were to look at the full text, you would see that this is a function call or a method call that has that in it, but I'm condensing the words down to just that one word there for the method call. So if we go back into colorizing the methods, you can see it a little better there. And we're going to hide the full text on that. Okay. So what I could do with this is, if I was, curious if, for example, if something like this step is being set prior to something else, well, just being able to map all this out and have it spatially here allows me to very instantly see that's the relationship. That's where this is set. That's how this is set. That's the order in which these things occur. And I don't get that from looking at the code, because this function could very easily be higher up or lower down than this function in the code. And being able to see this and see that this goes here, it goes here, it goes here, it goes here, it goes here, that relationship is fundamental to how this code operates, but it's something that I just honestly don't get from looking at code itself. Anyway, this is the advantage. This is the use case for spatial computing. This is the ability to take your code, which only exists as text, and see it and take advantage of your body and your brain's ability to spatially map the environment around it to information. And so you can very easily see how things work, and then you can very easily remember how they work. So later today, if I'm trying to remember something, I will remember this. I'll know this. In fact, I'll probably at some point even think it's right behind me on the wall, even though it's not. And that right there is the use case, the justification for buying a VR headset if you're a programmer. So if you would like to get your hands on this and you have a Meta Quest 3, hit me up. Let me know, and I'll put you in the beta program. You don't need a copy of CodeWalker to use it, because it has a demo file that you can use. But if you want to use it with your own code, you'll need a full version of CodeWalker, which is on Steam. Okay, that's it. I hope you learned something, and I really think this is I created this tool to help me solve some of the hardest problems I ran into, and I know it can help you solve some of yours. I hope it helps. Thanks. Have a great day.